In this video, we'll solve a system of three equations with three variables. So the direction is solve the system. It has three equations, so I'm going to label equation 1, equation 2, equation 3, and it has three variables, x, y, and z. So it's a 3 by 3. So how do we solve it? Well, first we copy equation 1 with an equation 2. We just copy them one under the other one, and we set to cancel one of the variables, so we can decide which one we want to cancel. So I want to cancel x, so to do that I'm going to multiply the second equation by -2. So the first equation, I just copy it, and the second equation, when we multiply by -2, we get -2x plus 4y minus 8z equals 20. So now let's add them up using elimination method. X is gone. Now 9y minus 7z equals 32. I put this in a box and I call it equation 4 because I might need it later. The next step is to copy equations 2 and 3. So x minus 2y plus 4z equals -10, and -3x plus 6y minus 12z equals 20. So because we eliminated x, I'm going to eliminate x from this one as well. So I cannot eliminate another one. So I'm going to multiply by 3 the first equation, and I get 3x minus 6y plus 12z equals -30, and -3x plus 6y minus 12z equals 20. When we add them up, we get this cancel, this cancel, this cancel. We get 0 equals -10, which is false. So the conclusion is no solution. No solution. So basically, we solved a system of three equations with three variables where we had no solution. There are no three numbers that when replaced in the first equation, second, and third, they give us true each time. And now let's solve one more system of 3 by 3 equations. So we have equation 1, equation 2, and equation 3. Now I'm going to copy equation 1 and 2. 7x minus 3y minus 4z equals 1, and 14x minus 6y minus 8z equals 2. And I'm going to eliminate, let's say, x. So in order to do that, I'm going to multiply the first equation by 2. So 14x minus 6y minus 8z equals 2. And 14x minus 6y minus 8z equals 2 as well. Well, I wanted to eliminate x, so it seems like I was supposed to multiply by -2, right? So -14x plus 6y plus 8z equals -2. So now when we add them, we get 0 on one side equals 0 on the other side, which is true, right? It's different than the second problem where we got something false. Now if I copy 2 and 3 together, 14x minus 6y minus 8z equals 2, and 21x minus 9y minus 12z equals 3. And I want to eliminate again one of the variables. Let's say I want to eliminate x. So I'm going to multiply this one by 3, and I'm going to multiply the second one by, let's say, -2. The first equation is going to be 42x minus 18y minus 24z equals 6, and -42x plus 18y plus 24z equals -6. So when we add them together, again we get 0 equals 0, which is true. So the conclusion is the system is dependent, which means, or the equations are dependent, which means that we have infinitely many solutions, and usually we write two of the variables in terms of 1, but we cannot in this case. So we are going to write x, y, and z with the property that 7x, and I'm just going to copy the first one, minus 3y minus 4z equals 1. So in other words, if I want to enumerate a few of the solutions, I can say, well, if x is 0 and y is 0, we can figure out z by replacing them in the equation, in this equation here. So we get 0 minus 4z equals 1, negative 4z equals 1, z equals negative 1/4. So negative 1/4. That would be one solution. If we choose x1 and y1, we can figure out z to be 7 minus 3 minus 4z equals 1. So 4 minus 4z equals 1. Negative 4z equals negative 3. Z equals 3/4. So here we put 3/4. And we can make up any numbers we want for x and y and find z. So these are two of the solutions, but we have infinitely many, only they have to satisfy this condition. And now let's solve a fourth example. It's still 3 by 3. I'm going to label the equations 1, 2, 3. And I noticed that the first equation it's missing z, so I'm just gonna keep it like that, and I'm gonna copy 2 and 3 and try to eliminate z from these equations so that I can put together the resulting equation with the equation that I just put in the box. So x plus y minus z equals 3, and then 2x plus 2y minus 2z equals 6. I want to eliminate z again because if we look at this equation, it doesn't have z. So I want one more equation without z. So to do that, I'm going to multiply this first equation by negative 2. So I get negative 2x minus 2y plus 2z equals negative 6. 2x plus 2y minus 2z equals 6. If we add them up, we get 0 equals 0, which is true. So it means the system is dependent. So, in other words, if I choose one of the variables x, y is going to depend on x, of the choice that we have for x, and z is going to depend on x as well. So in order to figure out those numbers, which if you think about it, we couldn't do it in the previous example, because when we copied and we tried to eliminate a variable from first two and from last two, we would always eliminate everything. But anyway, if I want to figure out what is the y here, I'm going to take this equation 1, 3x plus y equals 5, and I'm going to solve it for y. So y equals negative 3x plus 5. So in here, negative 3x plus 5. So y variable, it's written in terms of the variable x. So that's why it's dependent. Y depends on x. And if I want to find z, I'm going to take the second equation and I'm going to copy it, x plus y minus z equals 3. Instead of y, I'm going to put this quantity, so x minus 3x plus 5 minus z equals 3, and I'm going to solve it for z. So negative 2x plus 5 minus z equals 3. I'm going to move the z in here and 3 in here. So negative 2x plus 2, right, because 5 minus 3 is 2, equals z. So in other words, here is going to be negative 2x plus 2. So x is x, y, so x is x, y is negative 3x plus 5, and z is negative 2x plus 1. So the system is dependent, but if I want to enumerate a few solutions, right, I can say, well, if x is 0, the next one is 5, and the next one is 2. So this is a pair. So there are infinitely many solutions, but they have some relation between them, right? Not randomly, not 0, 0, 0, 0, 0, 1. They have some connections between them. So if x, I choose it to be 1, Y is going to be, well, I replace in here, so it's negative 3 times 1 plus 5, that's 2. And Z is going to be 0. So I can go on like this forever, right? Because infinitely many solutions. If X is negative 1, Y is 8, right? Because I go here and I say negative 3 times negative 1 is 3 plus 5, it's 8. And then to find Z, negative 2 times negative 1, it's 2, plus 2, it's 4. And so on, right? So the final solution is given by this, right? It's this triple, but we say there are infinitely many solutions with the condition that the first one is x, the second one is negative 3x plus 5, and the third one is negative 2x plus 2.